In this problem, we're looking at a crate that's accelerating across a floor. So the coordinate system we're using is up is the positive y direction, to the right is positive x. Since the crate's speeding up to the right, we know that it's going to the right, so velocity's to the right, acceleration's also to the right, so that makes this positive. We're going to be looking for the normal force and the coefficient of kinetic friction. Both of those are going to be positive. The magnitude of the normal force, which is what we're always finding using the second law, it's always the magnitude, so it's going to come out positive. We're going to be getting the normal force in units of newtons and no units for the coefficient of friction. As in all of these chapter 4 and 5 problems, we're using Newton's second law. There's only one object of interest here, which is the crate. We also have this additional frictional kinetic friction equation. So let's go ahead and get started. We're going to take this equation and we're going to say the normal force minus the weight, and the weight is mg, 1200 kilograms, times 9.8 meters per second squared, minus 400 newtons, equals the mass, which I could write in, it's 1200, but the acceleration in the y direction is equal to 0. And I just looked up here and I see that I wrote AY equals 2.5, but that's the acceleration to the right. And so I wasn't thinking clearly when I wrote that. That is a sub x. And so that's one of the things is you're going to write things down incorrectly as well, but always be thinking about what you're doing as you're doing it. Don't just move on blindly. Just because I wrote that down as a sub y doesn't mean I'm going to trust that that's what was totally correct, and it was definitely wrong. Alright, so now I can go ahead and solve this. I can put this into my calculator. I get 12,160 newtons. Actually negative, but then I add it to both sides, and so I get positive 12,160 newtons. Next up, I'm going to take the second law equation in the x direction. I'll just say I'll do this right here. So in the x direction I have 5,500 newtons minus Fk equals 1200 kilograms times positive 2.50 meters per second squared. And that's the a sub x, as I just talked about a moment ago. And so we can find out F sub k. Do the algebra here. 5,500 minus 1200 times 2.5. We get 2,500 newtons for the force of friction. If you would like to show more algebraic steps than I just did right here, I welcome you to do so. It's a good idea to show more steps rather than less. I have quite a bit of experience doing algebra, and so doing these 3 steps in my head did not bother me. Alright. Now, that is not what we were asked to find. We were not asked to find the force of friction, but rather the coefficient of friction. And so now we take our final equation here. Let's draw a line here like this. And so we say 2,500 newtons equals mu k times 12,160 newtons. We divide both sides by 12,160. We get 0.206. And we're dividing newtons by newtons, and so we get no answer, no unit for our answer of coefficient of friction. The signs were both positive, which we expected. We got the right units. We did answer all the parts. Are the magnitudes reasonable? Yes, the normal force is just a bit more than the weight. And that makes sense because somebody was pushing down with an extra 400 newtons of force. Coefficient of kinetic friction is a positive value. It's less than 1. And so That's right in line with what we would expect for coefficient of kinetic friction.